All right, so I got a request to do some algebra word problems specifically for test prep. So we'll see how this goes. I got 3 problems for you, and then we'll just check them out and do them as they are. They're actually kind of a little bit interesting. Okay, so the first problem is basically, and I wrote this up on the board already, but the original problem is Lynn can type a page in P minutes. What piece of the page can she do in 5 minutes? And so I have some words underlined, and those are words that should always kind of stand out. Whenever you do math or you are applying math, you can have, there are numbers involved, but you also want to have what are called units. Units are units of measurement. You can have random numbers, but if they don't mean anything, I went 5 compared to I went 5 feet, that's a big difference, right? You need to know exactly what you're talking about. And that can actually help you problem solve. So in this case, it says Lynn can type a page in P minutes. What piece of the page can she do in 5 minutes? So um, you're going to end up actually having a fraction here. And so you can type a page in P minutes. So automatically, you're going to have one, let me just write here, one page in P minutes. And so it says, what piece of the page can she do in 5 minutes? So this is where it gets a little interesting and stuff. So we have this fraction. You can notice we have pages on top and minutes on the bottom. We're asking for the answer is in terms of pages, not minutes. So we need to get rid of the minutes, right? In algebra, in order to get rid of any sort of unit, if a unit is on the denominator or the bottom of the fraction, we need to make sure we multiply the fraction by the same unit on top to get rid of it so that they cancel out. And so in this case, we're given what piece of the page can she do in 5 minutes, which means we're going to be multiplying this answer, multiplied by 5 minutes. That's going to be in parentheses, divided by 1, right? And this is really our problem, not too bad, right? And so what it's going to end up going on here is that our minutes are going to be canceling out. We're going to get rid of those. And our final answer is we're going to have, she can do 5 pages divided by P. And this is going to be in terms of pages. That's how many pages she can do. So if we were given a number for P, we'd be able to plug it in, but because we weren't, this is as good as we can get it. And this is our first problem. So our first word problem, a little bit interesting, little difficult, but we'll just keep going. All right. So the second guy is, this one's actually a little hard too. Excuse me. And it says, if Sally can paint a house in 4 hours and John can paint the same house in 6 hours, how long will it take for both of them to paint the house together? So you got, let's just see here. Let's go back to blue. So let's just say we have Sally can paint in, she can paint in 4 hours. And then you have, what was his name? John, Jeremy, John. And then you have John, John, in 6 hours. Okay. So again, this is kind of like the first word problem where you're also going to be dealing with fractions. Remember your units here. So Sally can paint one house in 4 hours. Okay. So here you're going to be doing Sally. We're going to just be writing this in terms of Sally. Sally can do one house in 4 hours. I'm going to disregard the units right now. I think you kind of understand it. And so remember that the two of them are working together, and you want to figure out how fast they can do it together. Together means addition, right? Because you want to sum them up together. So this is Sally's time. And then if we do the same thing with John, let's just say John can paint one house in 6 hours. So it's going to be 1 divided by 6, right? And that's going to be equal to something. And let's actually think about this for a second. What is this going to be equal to? Well, let's think of our units. We have houses on top and then hours on bottom, right? If these two are working on the same house together, then our units have to match. So let's just say, I'll write this down here. Whatever our answer is, we're going to have houses on top and then hours on bottom, right? But the thing is, we know the houses because they're both working on the same house, one house. So therefore houses is one, right? I'll come down here. Houses is one, but we want to know how long it takes them. And so that is in hours. So let's just put that, let's just say as a variable X. Okay. All right. And this is our starting problem. Cool. This is not our final solution. This is just the problem to get started. This is always the hardest part, in my opinion. So we want to, in this case, we want to solve for X, and I personally don't like fractions. And so the golden rule of algebra is you can do whatever you want to one side of the equation as long as you do it to the other side. And so in this case, I want to get X out of the denominator. And so I know that if I multiply a X over 1 on the right-hand side, and I do it on the left-hand side, I can get rid of the X in the denominator on the right. So let me go to a brand new page. And so let me write, I'll also get more room here. So our problem was 1/4 plus 1/6 is equal to 1 over X. Okay, so that was our original problem, right? And so what I'm going to do is I'm going to multiply X over 1, X over 1 by both sides. 1 over 4 plus 1 over 6 equals, and then I have 1 over X. And remember, I have to do both sides, right? So X over 1. Okay. And now what I need to do is basically multiply these X's on either side to all individual terms. So that means that this X on the left-hand side is going to be multiplied by this term, and it's also going to be multiplied by the second term. The one on the right-hand side is going to be multiplied by here. So let's slow down. We'll do one at a time. So X over 1 times 1/4, right? X times 1 is X. 1 times 4 is 4. Right? When it comes to multiplying fractions, we multiply straight across. Very easy. Okay. Then we still add, and then we're going to do the same thing. X times 1 is X. 1 times 6 is 6 equals. And this one's interesting. Let's go to the right-hand side now. So we're going to do X times 1 is X, and 1 times X is X. And so technically we have X over X. But as you might recall, any number divided by itself is just 1. So it doesn't matter what X is. I'll give you an example of 2 divided by 2. How many times does 2 go into itself? Just 1 time. So therefore, this X over X, we can rewrite it as being equal to 1. Okay, cool. We still have a couple more things to do, but it's going to be super similar. I personally don't like this 4 or this 6 here in the bottom. So what we're going to be doing is we're going to be multiplying both sides again, except this time we're going to be multiplying it by, let's just do 4 to get rid of this 4. So it's going to be 4 over 1 and 4 over 1. Okay, same thing. 4 is going to be multiplied by here. Okay, so 4 times X is just 4X. 1 times 4 is just 4. Plus 4 times X is just 4X. 1 times 6 is just 6. Okay, and then 1 times 4 over 1, or 1 times 4, is just 4. Okay, now we can actually simplify this. We know that for X over 4, the 4s are going to cancel because it's a product. You're multiplying 4 times X. You're allowed to do it. Cool. So we can simplify this guy to X plus, and I'm going to leave this term even though I can reduce it still. You can get the right answer either way, but I find it's just easier. To be 4X over 6 is equal to 4. And we're very, very close. Let's get rid of this 6. And so same thing once more. Let's multiply again. 6 over 1 on the left-hand side and 6 over 1 on the right-hand side. Okay, so let's do this one more time. We're going to be multiplying that guy by there and then this guy by here. So I'm going to come up here. And so 6 times x, we're just going to get 6x, right? And then 6 times a 4x, 6 times 4, you're going to multiply your constants together. 6 times 4 is 24, multiplied by x is 24x, right? But if you kind of notice, we have a 6, we're going to have a 6 in the numerator. We're also going to have a 6 in the denominator. So the 6's actually cancel. We're just left with 4x, okay? 4x. And then we have 6 times 24, right? 6 times 4, which is 24, my bad. Okay, almost done here. So what do we have now? We have 6x plus 4x is equal to 24. We aren't done because our problem said we need to solve for x. X is in terms of hours, right? So let's add these guys together and then see if we can figure this out. So 6x plus 4x, 6 plus 4 is 10. Therefore, we have 10x is equal to 24. Okay, and then what we can do now, our problem asked us to solve for x. And so we're going to divide both sides by 10. All right, now 10 over 10 is just 1. We know that guy. And then we have x is equal to 24 divided by 10. This is going to be in terms of hours. So what we're going to be doing is we're taking 24 divided by 10, and that should be giving us 2.4. So x is equal to 2.4 hours. And let's check. Let's see what everyone else says here. Right. And 2.4 hours. That is our solution. That's exactly right. Cool. Excellent. That one was actually a little bit of some work, and the hardest part about word problems is setting up the problem. If you have the algebra basics, you can pretty much do what you want, but setting up the problem will almost always be the hardest thing you'll ever do when it comes to math. Guaranteed. So, and with that, I'm going to go to our third problem, third and last problem. And it basically is just sort of a percentage slash fractions problem when it comes to like prices and stuff. So the problem reads, employees of a discount appliance store receive an additional 20% off of the lowest price of an item. If an employee purchases a dishwasher during the 15% off sale, how much will he pay if the dishwasher originally cost $450? So what I'm going to do is I'm going to actually copy this guy here, and I'm going to put text. Let's see. There we go. There we go. Hopefully you guys can see that. Okay. So that's the problem. It's probably easier to see it. And so let's do this, man. All right. So employees of a discount appliance store receive an additional 20% off of the lowest price of an item. If an employee purchases a dishwasher during a 15% off sale, how much will he pay if the dishwasher originally cost $450? So when it comes to this stuff, and I'm sure you've been in a grocery store before, whenever you have a certain percentage off, you're going to take your percentage, and the algorithm for this is take your percentage, turn your percentage into a decimal, multiply that decimal by the total, and then subtract that from the total, and that's what you get. So I'll give you a minor example here. Let's just say I have a toy car, right? And the toy car, let's just say toy car, and it happens to be equal $200, okay? And it happens to be 50% off. 50% off. Okay, so let's turn the 50% into a fraction. And so what you do is you take the 50 and you divide it by 100. And that will give you your fractional form and of your percentage, your fractional form, and you can go from fractional form to decimal. You can use a calculator for that, very easy. So in this case, now you have 50 divided by 100. And I know I can reduce this because 50 goes into 100 twice. So this is going to be 1/2. Cool. So I wanted this guy. So if the toy car was $200, but now it's 50% off, how much am I going to pay for this? Right. So what I need to do is I need to do let me erase this guy here. There we go. I need to take my toy car, which is $200, right? And I'm going to multiply it by 1/2. And remember, any number like 200 immediately turn to a fraction over 1, right? And with fractions, you multiply straight across. So 200 times 1 is just 200. And then 1 times 2 is 2. 200 divided by 2, everyone knows is 100. But you have to remember, this is the discount price. This is not the actual price you're going to pay. There could be a difference. Because I know where this answer is going, I already know that this actually, the $100 will be our final price. But remember, this is the discount price, not the price that you actually pay. So what you want is the original price. Let's just say original price minus the discount price. And that is our answer. This will be our answer. This is our groundwork for our answer. So the original price in this case was $200, right? $200, and then our discount price, as we found out down here, is $100, right? Because it's 50% off. 200 minus 100 happens to be equal to 100. Excuse me, happens to be equal to 100, but that is not always the case. That the price you pay is equal to the discount price, right? So it's a quick tutorial on how to change percentages into fractions. Take that, whatever number is your percentage, divide it by 100, turns it to a fraction. To find out the price you will be paying for the product is your original price minus your discount price. How do you find your discount price? Your discount price, and I'll put this down here, your discount, excuse my horrible handwriting, your discount price is your original price times whatever percentage you have off. And there you go. So now that we did that, let me erase all this stuff here. All right. Used a lot of purple, huh? Cool. All right, and I'm going to keep this guy up, the original price minus the discount price. Okay, so let's do a different color now. Let's do maybe red. All right, so employees of a discount appliance store receive an additional 20% off the lowest price of an item. If an employee purchases a dishwasher during a 15% off sale, how much will he pay if the dishwasher originally cost $450? So here they're trying to trick you, and just a little bit. And so they're giving you 2 percentages instead of 1. One of these percentages is actually already applied before the employee gets to the product. Now that one is your 15% off. So let's go and let's just do our percentages right off. So 15%, if we're going to turn that into a decimal, we're going to have 15 divided by 100. And I already know that off the top of my head, which is just 0.15, right? I could leave it as a fraction like that, or turn it into a decimal, whatever you want. Let's just get the 20% out of the way, right? So 20% is just equal to 20 over 100, which I know is also equal to 0.20. You could reduce these fractions down to different numbers, whatever you want, right? And let's just keep this guy up here, okay? Okay, so now that we did that, before the employee actually gets to this item, the item is already discounted off by 15%, which means that 450 is not the actual price that this employee is looking at the moment, right? It's going to be something else. It's going to be $450 dollars with 15% off. So that means that we have to do two of these multiplication by percentages, if that makes sense. So let's do that. So let's do, remember our thing was we're going to take our total price, which in this case was 450, and we're going to be multiplying it by 15% off because we want to figure out what is the price that the employee is looking at it before the employee puts their own discount on it. So 450 times 15%. 15% is, as we stated, 15 over 100 or 0.15. Let's just do 15 over 100, right? And because I am very cheap, I'm going to put this into my calculator. So we're going to do 450 times 15 over 100. And hang on, 450 times 15 divided by 100. Cool. And so what I get as my answer here is I get 135 divided by 2, or 67.5. Remember, this is in dollars, this is in dollars, and this is in dollars. These are the same things. One's in fractional form, one's in decimal form. This is not the price. Remember, this is not the price that the employee is looking at. This is just the discount. So as we said over here, the original price minus the discount is equal to the actual price. So the actual price of what the employee is looking at is equal to 450 minus, let's just do the decimal one, 67.5. These are both in dollars, okay? And so let's do this for, cool. And that leaves us with, in dollars, 382.5. Cool. So this is the price that the employee looks at before the employee puts their own 20% discount on. Okay. So what does that mean? Well, we figured out, let's cross this guy out here in purple. So we did the 15%. Done with that. Completely done with that. Now I got to do the 20%, which means we got to do the whole thing over again, but now just with the 20%, except we're not starting with 450. We're now starting with $382.50. So let me get us some room here. We're going to do the exact same thing. And we're going to be doing this guy. So now we're going to be doing $382.50, right? Remember to kind of just keep this guy in your head real quick. Let me erase this. All right, let's just do this in like a different color here for everyone. Okay, so now we're going to say we need to find out the discount price of $382 when the employee puts their discount on it. So how do we do that? We multiplied this price, the original price or the actual price, by the discount price. So let's take $382.50 and we're going to multiply that by the 20%, or 20 over 100. Again, you can turn any number into a fraction over 1, and with multiplication of fractions, multiply straight across. And again, I'm going to use my calculator here. 82.5 times 20 divided by 100. And you are going to get, your fractional form is 153 divided by 2. This isn't dollars again, or again, this is in dollars, the same thing, is $76.50. So this is, again, the discount price. It is not what the employee would be paying. It is what the employee would be saving. Okay. So in order to get the price that the employee will be paying, we need to look at our purple formula over here and take the original price. Our new original price is $382.50 and our discount price, which is this $76.50. So let's go and do that real quick. Let me do this in green. So our answer, this is our final answer, I promise, equals $382.50 minus 76.50, right? And so we have 382.5 minus 76.5, which is going to be equal to $306. $306.00. This is our final answer, right? So let's check it. Let's see what everyone else says. $306. There we go. So the reason why we kind of have to do this in multiple steps, some people might be asking, why can't we just add the percentages together and then find out the original and the discount price from that and find our solution from that? So if you were to do that, you could add the 20% and the 15%. That would give you 35% because 20 plus 15 is 35. Turn that into a fraction or a decimal. That's going to be 0.35. 0.35 of your original price, 450, is actually a lot more. And so you have to be careful. You would actually end up with much less. I think it was like near $150 or so. And that's not quite accurate. So the percentages, each percentage is applied at different times and to different numbers, and they mean something. So just remember the order of which you need to do it in, as that is. So this is our final solution. So good job. So first 3 problems of algebra test stuff.